Here we have a velocity time graph that represents an electric train on a straight portion of the track where positive velocities are to the right and negative velocities to the left. Let's remember that on a velocity time graph, according to my acronym DIVA, if I take the slope, I'll get the acceleration, and if I take the area, then I'll get the distance or the displacement. My first question: during what time interval is the train at rest? To be at rest, you have to have 0 speed. From 3 to 5 seconds, my speed was 0. During what time interval is the train moving to the right? Positive velocities mean that you're moving to the right, so from 0 to 3 seconds we had a positive velocity. When was my train moving to the left? When I have a negative velocity, which is from 5 seconds through 10 seconds. During what time interval is the train moving with a constant velocity? In other words, an unchanging velocity. So from 0 to 2 seconds, and also from 7 to 10 seconds, I was moving with an unchanging velocity. I would not include 3 to 5 seconds because while the velocity is unchanging, it's 0, and so I'm not moving. During what time intervals is the train accelerating? In other words, when is it changing velocities? From 2 to 3 seconds, and from 5 to 7 seconds. How far did the train travel in the first 2 seconds? That's asking me for the distance, so I should take the area of this rectangle. Okay. So the area of a rectangle is just base times height. So my base is 2 seconds long. My height is 2 meters per second. Notice that seconds times meters per second will just give me meters, and I get 4 meters as my answer. The next question asks how far I traveled in 3 seconds. So I want to add on the area of this triangle. So area of a triangle is 1/2 base times height. So 1/2, the base is 1 second, right? From 2 to 3 seconds is 1 second. And the height is 2 meters per second. I get another meter. And so the distance I moved from 0 to 3 seconds would be my 4 meters plus my 1 meter, which is 5 meters. Next I asked how far the train traveled in 7 seconds. So I want to add on the area of this triangle. Right, I don't have to worry about 3 to 5 because I wasn't moving. But from 5 to 7, I was moving backwards. The area of this triangle, again, 1/2 base times height. So 1/2, the base is 2 seconds. Notice the height is -1 meter per second. So this comes out to be -1 meter. So far, I went forward 4 meters. I went forward 1 more meter, so I went forward 5 meters. And now I've gone back 1 meter. For letter I, what's the distance? So while I've gone forward 5 meters and backwards 1, the total distance I traveled was actually 6. Right? Forward 5, backwards 1. But in letter I, they don't ask me the distance I traveled, they ask me my displacement. I walked forward 5 and back 1. That makes my displacement 4 meters in the positive direction, which is 4 meters to the right. Letter J. What's the train's displacement after 10 seconds? Now I got to add on this area over here. The area of that rectangle is base times height. 3 seconds, -1 meter per second. I get -3 meters. Keep in mind that the question was for displacement. So I walked forward 5, backwards 1, so now I'm still forward 4. And I go backwards another 3, so I'm still forward by 1. I'm in the positive 1 meters is my displacement, which means 1 meter to the right of where I started. The last question. If the train continues at 1 meter per second, -1 meter per second, or 1 meter per second to the left, when will it get back to its starting point? So we know that right here, we are 1 meter to the right of where we started. We need to figure out how much more do I have to go over to get an area of another -1 to get me back to where I started. Well, I know the height of this is -1 meter per second. So an area of a rectangle, which is base times height, I want the area of my rectangle to be -1 meter. I know that my height is going to be -1 meter per second. And so the base needs to be 1 second. That means here at 11 seconds, 1 second after 10 seconds, at 11 seconds I'm back where I started, and my displacement is 0.